Hello, I'm Professor Steven Neshyba, and I'm here to help you out with constructing an atmosphere-free model. So I've already set up an Excel sheet here with these categories. Where this is the solar constant, which you can just enter by typing in the letters. Here I'm going to enter numbers, and I know that 1367 is the watts per meter squared for the solar constant. For Earth, the albedo is 0.3. Sigma, I'm going to enter in scientific notation as 5.67 times 10 to the minus 8. That's 5678. And it's a lot easier to do that in scientific notation. So the temperature, I'm just going to start with 100 degrees because even though I know that's not the right answer, we're going to have Excel figure out the right answer. And let's see. Oh, well, here now is going to be our first instance of entering an expression which starts with an equal sign. And what I'm going to do is I'm going to say that equals that number here, but instead of typing in 1367 again, I'm going to just click on that box, which is B2, and I want to divide it by 4, so that's what I'm doing there. And now I1 prime and I2 prime, these are the shortwave and longwave contributions to the radiative balance of a planet, and so I'm going to also put these as expressions, and that's what you should do too. So I'm going to say that's equal to, now I know that it's S naught over 4 times, and now you have to use the regular order of operations, 1 minus the albedo. And so that's that one there. And then what else do we want? Oh, I want for the outgoing long wave radiance. I'm also going to put in an expression. And I know that that's sigma times, so there's sigma times, and I'm going to say enter the temperature field there, raise to the 4th. Okay, and so I've got that. Now, what about the radiative difference? Well, it's another expression. I'm going to say it's equal to I1 minus I2. And as you can see, we're not in radiative balance. I1, because this is positive, I1 is a lot bigger than I2. But that's because our temperature is so low. So the last thing that we're going to do here is I'm going to have Excel figure out the proper value of the temperature, and in order to do that, I have to do this thing called goal seek, and that comes on this what if analysis under the data tab. And here's how it goes. Under what if analysis, I'm going to select goal seek. And the whole deal is I want to set cell B9, that's this one right here, to a value of 0 by changing the temperature, which I can see is in cell B2, or sorry, B5. And that all looks good, so I'm going to say OK. And what it's done is it said, okay, I have found that at a temperature of 254.8, the difference, the radiative imbalance, the difference between I1 prime and I2 prime is a very small number, as you can see from here. So we say, well, look at this. That's just great. We found a temperature of 254.8. So that would be the predicted temperature of our planet using the atmosphere-free model.